Next, we'll be talking about Newton's third law of motion. Now, Newton's third law of motion is a bit special. It doesn't actually involve any kind of resultant force itself. First thing, Newton's law of motion says that for every force, this is what we're going to call an action force or just action itself. Okay, that A acts on B. So for every single force that you have, B will exert an equal and opposite force on A. This is what we call your reaction, or more specifically, your reaction force. Okay, let me just rewrite this. Reaction. Handwriting is not very good. Reaction force. Okay. So together, these two are called a action and reaction pair because there's two of them. Okay. So what is the unique characteristics of this action-reaction pair itself? First things first, you must have the same nature. Now, when we say same nature itself, we're actually referring to the same type of force. For example, if you see over here, if the action is a gravitational force, reaction must also be a gravitational force. If you clap your hands, both of your hands will hurt, right? It's because when you move your hands together, there's an applied force on the other hand, and your reaction will be your left hand applying also an applied force back on your right hand itself. So that's why normally when you clap your hands together, your hands get tired. Same thing as that, right? Now, next is that they must have the same magnitude. 5 Newton action, 5 Newton reaction, same thing. And they are now going to act in opposite directions. One will be up, one will be down. Or your action is left, your reaction is right. And this one, different bodies. They are going to act on 2 different bodies. Only 2 different bodies. Okay? Because this is a pair, not a trio. There's only 2 objects. A on B, B on A. Okay? There are 2 different objects. You need to be very, very careful. They are separate. Okay? Now, just be careful. If it's a 2-mark question, you need to include all 4 of them. If it's just a 1-mark question, just add in the ones that you remember. Okay, so if you want to play it safe, just remember all of them and use all of them in your explanation itself. Okay, so if you notice this man who is doing a push-up, okay, he's doing a push-up. First thing when we do a push-up, what happens? We're actually pushing on the ground. So this is your action. I'll use green color. Okay, this is your action. Once you push the ground, what happens? You will realize that the ground doesn't move. Instead, you are the one that is moving upwards. Why is that so? Because there is a reaction. If you notice, first thing, your action it is on the floor, but your reaction will be on the man itself. This is on A, this is on B. And you see that A on B, B on A, they are slightly different. Okay? And if you notice over here, same thing. They are also the same type of force. And if you notice the direction, this is down, this is up. They are opposite directions. So can you see everything is exactly the same? And to be even more specific, can you see that the length is also the same, which means that they have the same magnitude as well. So even though this diagram looks very, very simple, oh, it's just like this, actually all the 4 parts, all the 4 characteristics are actually hidden in the diagram itself. Especially for the schools that are very, very strict, like MGS, CHS, all the named schools, right? Basically, make sure that your length of the arrows are about the same, or just use a ruler and measure the same length. Okay? Because there have been cases, especially for MGS, where your lengths, if they are not the same, you actually get penalized marks. So you need to be very, very careful about all of this. So do take note about this. All right? So you can see over here, applied force, downwards, upwards, on floor, on man, different. So you can see over here, when he pushed down on the floor pushed back up with the same force in the opposite directions, and therefore he will move upwards. Similarly, if you want to talk about literally any object on Earth, every object on Earth will have gravitational force, which is your weight, correct? So every one of us, even yourself, because we are standing on the Earth is acting on us. Okay, and it is a downward weight, correct? If you just draw your favorite box, weight will always be downward. So what happens? If you look at the Earth, the earth will also be put upwards by the weight of okay, so you can see over here, same thing, you also have weights, but now it is on the earth. Okay, so basically, even though the earth is pulling us down, we as humans, as any kind of object with mass, we are actually pulling the earth up as well. Okay, because of action reaction force. The only reason why the earth doesn't move is because it is much, much, much bigger than us. So because of this, the earth doesn't really move very much compared to us, which is much, much, much smaller compared to the earth. Okay, so because of this itself, you can see the earth is the one pulling us down, and that's why we will fall downwards, while your skydiver will actually pull the earth up. But take note, because the mass is very, very big, don't forget, this is W equals to mg, right? Now, what this means is that both of the W's are actually the same, but because the earth is very big, okay, this means that G must be small, okay, for you to have the same weight. Right? Next part, let's take, oh, before I forget, do take note, if let's say we have a table and we have a book sitting on the table. Okay, now because of the book itself is resting on the table, some students, oh, let's draw the free body diagram. Okay, let's draw a free body diagram of the book. You will have weight, correct? You also have normal contact force. Because what? Because the book is not moving, this is stationary, so normal force. Some students think, hey, Cher, is this W and N action reaction pair? Answer is no. Why? First thing, you need to ask yourself your four conditions. Yes, they have the same magnitude, which is correct. Okay, so this one, okay. They have opposite directions, which is okay as well. But they are not same nature or same type. So the moment you have this wrong, they are not action-reaction pairs. And furthermore, both act on same object, which is wrong. Your action-reaction pairs, your action-reaction pairs must act on different objects. You must act on the book, you must act on something else. Okay, so because of this, they are not action-reaction pairs. So all your free body diagrams are never free body action-reaction pairs. But what you can do, on the other hand, which is the correct one, okay, the correct one, correct, is you just choose. Because in a free body diagram, you see you have weight and normal contact force, right? So let's say I choose the action. Okay, I'm going to choose the normal force. This is an upward normal force on the book. And what is this caused by? This is caused by the table. So your reaction will be a downwards. Okay, just the opposite of this. Downwards and same normal force, because action reaction pair must have the same type. And now instead of the book, I'll use on the table by the book. So you literally just swap these two around. So can you see that this is your actual action reaction pair, not this one? Okay, so basically if you want to solve action reaction pairs, you pick one of the force from your free body diagram, and then you will write it out fully, the direction, the type of force, what object is acting on, and if you have the number, you put in the number as well. Your reaction force will be according to your four characteristics up here again. So make sure you memorize these four characteristics. Okay, so just be careful, because not all the time the question will be so nice to give us such a clean diagram itself. Sometimes they'll give you more than 2 objects. They can give you 3, they can give you 4 objects. You need to be able to identify which is which. Okay, so next. Basically, this question, this example is just a summary of your Newton's 3 laws. 1, 2, 3 laws. Okay, so first things first, let's take a look at the question. They tell you that you have an initial acceleration of this. So whenever you have acceleration, first thing, we will use either acceleration formula or we'll use resultant force is ma. Okay? And they tell you that your mass, total mass, including rocket and fuel, is 40,000 kg. And last but not least, G is 10. All right? Now, they want you to find the weight. So weight, we just use the formula, W is mg. Always make sure to write the formula down. And because we're using a formula, double check SI units. Is everything SI units? Or is good? So 40,000 times 10. End up with 400,000 newtons. Don't forget, weight is a force. Then next, they tell you what's the resultant force. So straight away, resultant force, normally we use F. Okay, so if you look at this, you have thrust of engine, you have weight. But because your rocket is moving up, we will use the thrust, which is applied force, minus weight equals to m times a. Then you notice we don't have F. We do have A, but we do have weight on top, but we do have F. It's not possible to find. So we actually just use m times a over here. Okay, we're just going to use this one. That's why we memorize the full formula, because we just need to plug and place which one do we have, which one can we use to solve. The question just wants us to find resultant force. We can straight away use F minus W if we have the numbers. But in this case, we do have the numbers, so we just use m times a. That's why we have equal signs. So m times a, same thing, your m is 40,000. And they tell you that your initial acceleration is 1.25. So you end up with 50,000. Just be careful, because there's a lot of numbers involved. Typically, if I have 3 zeros, I will leave a gap in between, like what you see up there. And then next, they ask you to find the upward thrust F. So you can see that when we write this formula out, you just need to put in your numbers now. You want to find the unknown F. Your weight is 400,000 in part A, and your resultant force MA is 50,000, which is what we calculated in part B. So all you need to do is solve algebra style. 1, 2, 3 newtons. So 450,000 newtons to have an up thrust to actually accelerate upwards 1.25. Okay. Next, they tell you that as the rocket rises, your fuel is used up. Your fuel used up, what happens? This means that mass decrease. Okay, if mass decrease, what does it mean? Mass decrease, weight also decrease. Okay. Explain how this will be affected while thrust is constant. And what is thrust? Thrust is your F. F is constant. So if you actually take a look, we do have our formula here, which is this, the one that we've been using, right? Okay, so how are we supposed to explain this now? Basically, if you notice these 5 over here, these RF, F, W, M, and A, they're all your keywords in your explanation. So let me jot it down in words so that I can answer this question. So first thing is when fuel is used up, the mass and weight, or to be more specific, the total mass and weight will decrease. Okay, so what happens? Since thrust is kept constant, the resultant force will increase. Okay, and if you notice, because we have more resultant force, as a result, the acceleration of the rocket will increase. Okay, so let me just reiterate again using the symbols. Basically, at the start, okay, mass decrease, your weight also decrease. Your resultant force is F minus W. So what does that mean? RF will decrease. And since RF is also equals to M times A, what happens? This means A will increase. You all see that? So basically, it's just a link between this formula on the right, the blue color one. But basically, we're going to choose selectively how do we approach the question. You can see as fuel is used up over here, Okay, as fuel is being used up, what happens? Your total mass and weight will decrease, which is this part over here. After that, thrust is constant, resultant force will increase. Why? Because thrust is constant, weight decrease. So you actually have more resultant force. Okay, so actually we do have numbers here. So if 450,000 is the same, this 50,000, this 400,000 here, let's say it drops to 350,000. Now your resultant force will be double, it will be 100,000. So you can see that the resultant force will actually increase, right? Sorry, I see my typo here. Okay, so just be careful. I will actually have more resultant force. Okay, because this guy will decrease. Okay. Then don't forget your mass decrease as your resultant force increase, acceleration will increase. Okay, so just be careful. Take note of this. All right, it's just using all the keywords inside here: mass, weight, thrust, resultant force, and acceleration. Can you see that all 5 of these in the equation are all mentioned over here on the right? Okay, so identify a pair of action-reaction pair of forces in this situation. So first thing, we have 2 forces, your thrust and your weight. You can choose either one of them as your action. Okay, so first thing first, oops. Okay, so action force. So when you want to state your action-reaction pair itself, first thing is we need to say there is then let's use weight. Sorry, let's use weight. There's a downwards gravitational force. Acting on the rocket because it's the weight of the rocket by the Earth. The reaction force. Okay, so maybe instead of saying there is, you can say that the action force is a downwards gravitational force. The reaction force is an upwards gravitational force. So both of them are gravitational force acting now on the Earth by the rocket. And if you notice, this is 1 mark, right? But what you can say is with the same magnitude as the action. Okay, so you can see over here, you have your direction, you have the type of force, you have the acting on different objects, and the last part here is that they have the same magnitude. So because of this, all 4 keywords have actually been mentioned. So you can see this is actually a very clear way to actually phrase all your answers properly. You all see that? So just be careful. Next one over here. A bag is dragged along the floor by a student itself. Explain whether state and explain whether your applied force P and frictional force F are action-reaction pairs. First thing, action-reaction pair, remember your 4 conditions. Applied and friction, why? They are not, all right? The 2 forces, P and F, are not action-reaction pairs. Are not a action-reaction pair because they are different. They have different natures. Or you can say different natures. That's one of them. They are different types of forces. Also can. You can also say that they both act on the same object, which is wrong. They must all act on different objects. So in this case, they are not action-reaction pair because your applied force is acting on the back and your frictional force is also acting on your back. So because of this, we cannot use this as an action-reaction pair. Do take note about this. Now, if not, state the other force itself. So actually, if you see this kind of question with a follow-up question, right? Most of the time, you know that part A answer should be if they are not action-reaction pairs. Okay, So state what's the other force that is an action-reaction pair with P. So now P is now your action. So what you want to do is you want to state what is the reaction force. The reaction force is because you're pulling the floor, it will be similarly an applied force acting. Now, instead of acting on the back, we are now acting on the student by the back. The back is now basically, if you pull the back will pull you back as well. That's why normally when you hold a plastic bag, your hand hurts, because when you actually lift up the plastic bag is actually pulling you down as well. So this is not all. Is the applied force acting on back, and then don't forget with the same magnitude. And because this question doesn't actually give us a diagram, so we don't know what direction this is, and opposite in direction. So can you see? I have stated the nature of the force. I have stated that now you're acting on different objects, and you have the same magnitude, and now you have different directions. Okay, and more specifically, it must be opposite directions. So because of this, you can see that we have mentioned all four things, and this is how you score your full marks for Newton's third law. Okay.